Forget everything you think you know about statistics. Seriously, forget the dusty textbooks, forget the boring math classes. Today, we're talking about statistics as a powerful, practical toolkit for making sense of our really complicated world. Okay, let's get into it.
You see stuff like this all the time, right? I mean, whether you're looking at your phone's screen time report, election polls, or your company's latest sales figures, we are basically swimming in an ocean of data. It's everywhere, and it's constantly telling us what to think, what to buy, what to worry about. So with all that information flying around, it's so easy to just feel overwhelmed. How do you separate the actual facts from the fiction? How can you look at a single chart and understand the bigger picture, the whole story? Well, that's the mystery we're going to start solving today. We're going to build our own statistical toolkit. So let's start at the very beginning and lay out the blueprint. What are we actually talking about when we even use the word statistics?
Well, what's really interesting is that the word statistics can mean two totally different things. The first one is what we all think of, right? The data itself. The stats from last night's game, the number of 5-star reviews for that thing you want to buy, the latest economic figures. These are just the raw numerical facts.
But here's the second, and honestly, the more powerful meaning. Statistics is also a science. It's the entire method, the process of collecting that data, cleaning it up, analyzing it, and then, this is the key part, using it to draw conclusions and make educated guesses. This is where we go from just having a pile of numbers to actually gaining real knowledge.
Okay, so to use our new tools, we've got to know what we're working with. And two of the most fundamental ideas here are population and sample. The population is the entire group we want to know something about. Let's say every single college student in the entire country. But trying to survey all of them, that's pretty much impossible. So what do? We study a sample, a smaller, more manageable piece of that group, like just 100 students. The whole magic of statistics is learning about the giant population just by looking at that one small, carefully chosen sample.
Now, let's open up our toolkit. You'll see it has two main compartments, kind of like two different lenses we can use to look at data. One is for describing what's already happened, and the other is for predicting what might happen next.
And this is a perfect way to see the difference. On the left, you've got descriptive statistics. Think of this like a sports commentator telling you a cricket player's average score over the last 20 games. It's just summarizing and describing data that already exists. It's a fact. But on the right, you have inferential statistics. Now, this is that same commentator using the player's past performance to predict how many runs they might score in the next game. See the difference? It's using a sample of past data to make an inference, a guess, about the future.
All right, we've got the big picture ideas down. Now let's zoom in and look at the real nuts and bolts. Because to understand the story data is trying to tell us, we have to speak its basic language. And that starts with something called variables.
So basically, every piece of data you collect is a variable, and they usually fall into one of two camps. First, you have qualitative variables. These describe a quality or a category. Think what kind. So your eye color, your nationality, those are qualitative. Then you have quantitative variables, and these are all about numbers. Think how much or how many. Your age, your weight, your income, all quantitative.
And we can get even more specific with those quantitative, number-based variables. A discrete variable is something you can count in whole numbers. You can have 1 car, 2 cars, or 15 cars in a parking lot. But you can't have like 3.7 cars, right? The values are distinct and separate. They're countable.
The other type is a continuous variable. This is something you measure, not count. So a person's height isn't just 5 feet or 6 feet. It could be 5'9½", or 5.82 feet, or even more precise than that. It can take on any value at all within a range. Okay, let's do a quick little pop quiz to see if you're with me. The variable is the age of a shopkeeper. So what do you think? Based on what we just talked about, is that discrete, meaning countable, or is it continuous, meaning measurable? Take a second. And the answer is continuous. If you got that, nice job. This is a tricky one, I know, because we usually say our age in whole years. But technically, your age is a measurement that is constantly changing, down to the month, the day, the second. It exists on a continuum. Okay, one last layer of detail here, and it's super important. There are 4 levels of measurement. Think of it like a ladder of precision. At the very bottom, you have nominal data, which just names categories, like male or female. There's no order to them. One step up is ordinal data, which adds a meaningful order. A rating of poor, good, excellent. We all know that excellence is better than good.
Then there's interval data, like temperature in Celsius. The gap between 10 and 20 degrees is the same as between 20 and 30, but 0 degrees doesn't mean there's no heat. Finally, at the very top, we have ratio data, which has a true, meaningful 0. 0 height literally means no height. This matters because the level of measurement determines what kind of math and analysis you're allowed to do.
So we've built our basic toolkit, we've got the core concepts, but just like any powerful tool, whether it's a hammer or a supercomputer, it's not just about what it is, it's all about how you use it. You see, good statistical work doesn't just happen by accident, it's a structured process. Before you even think about collecting data, you have to know your goal. You have to define exactly what and who you're studying, and you have to plan how you'll analyze it. But here's the thing. Every single step in this process is an opportunity for error, and sometimes for deliberate manipulation.
And this right here is probably the most important part of our entire conversation today. This exact same toolkit that can be used to discover life-saving medical breakthroughs can also be used to confuse, to manipulate, and to flat-out mislead people.
This quote has been famous for over 100 years for a very good reason. It's a powerful reminder that numbers don't just speak for themselves. The way they are framed, presented, and interpreted is what gives them their meaning. And that process can be incredibly dishonest.
So what are the red flags you should be on the lookout for? Well, a classic trick is using a sample that doesn't actually represent the whole group, like polling only people with landlines to predict a modern election. Another is using a tiny sample size to make some huge sweeping claim. And you should always look closely at graphs. It is so easy to stretch an axis to make a tiny change look like a massive deal. These tricks prey on our instinct to trust what we see. Just being aware of them is your best defense.
So in the end, statistics isn't just about math. It's about critical thinking. It's a lens for looking at the world with a bit more clarity, and it's a toolkit for asking better questions. We've really only scratched the surface today, but you now have the fundamental concepts. So the only question left is how are you going to use them to cut through all the noise?